Hello and welcome everyone. I'm Kaustav Ghosh, advanced computer science student from the Department of Computer Science in the University of Exeter, UK. I would be presenting my master's thesis on prompt optimization for generative art models. I would like to introduce my topic in a clear way. My project is in text generative AI art. As we all know, AI had a huge boom in the year of 2023. uh, Even though ChatGPT got all the spotlight from it from the worldwide audience, there were other very high advances made in the domain of AI, namely in the domain of generative art. Uh, so the software I'm working with is known as Midjourney. It is a software which uses texts to generate AI images. Now, Midjourney also had huge uh, updates in its models and systems in the year of 2023. It's almost unrecognizable how good it has become from its initial prototype variants. My project plan revolves around problem definition, data collection and cleaning, machine learning, optimization, and results, and the next steps, which we would take after our projects and our logical thinking. Problem definition. AI art can be enhanced by simply by improving the prompt we use. We do not need to go too deep into the model. The model themselves are being enhanced by a lot of companies. So I thought, why not just improve the prompt itself? The prompt that user provides may or may not be ideal for our ideal or desired images. So in order to do that, I would like to identify user prompts which are non-ideal and make them into optimized prompts using an optimizer. Uh, so for the data collection and cleaning part, for our project, we have chosen Midjourney prompt data from Kaggle. It's a openly available data source, and the data is basically text messages that the users of Midjourney have put on an app called Discord to interact with the Midjourney bot, which returns an image upon the user's messages based on the user's prompts, basically. All the data available in this particular data field is in the JSON format, which we got from Kaggle. I would like to say that 70% of my work actually revolved around aggregating the data provided in the Kaggle repository and cleaning it. That was a Herculean process. Like, even though there were lots of guidelines on Kaggle on how to extract the data and how to clean the data, no, I would say cleaning less so, but more or less on the extraction part, it was extremely hard to pinpoint random things that users had put in their prompts while they were looking for better outcomes. Now we move on to our next phase of our project, which is the machine learning. For our model architecture, we have chosen three basic RNNs: a normal RNN, a LSTM, and a GRU. RNN is a recurrent neural network. LSTM is a long short-term memory. And GRU is a gated recurrent unit. All three of them are based around NLP, because even though we are optimizing the image, we are actually optimizing the prompt to optimize the image in the long run. So it boils down to an NLP problem at the end of the day. So for training, one important part of training the data set was splitting the data set, and we split it into like two halves, which is in a ratio of 2:8, testing to training. This allows the model to evaluate, like based on like how it can evaluate its performance as well because of the split. And we had to choose the split very carefully so that it doesn't represent like there's no overfitting or underfitting. A large training set did help in like getting a better overall performance, but we did try our best to not have like an overfitted model. Um, Now we move on to LSTM. LSTM is long short-term memory model. It's a recurrent neural network that is very common in natural language processing because it remembers like long like memories. It helps in like identifying prompts which may or may not be upscaled by users. So the way we are deciding whether a prompt is good or bad and or needs to be optimized or not is whether a user has upscaled a particular image obtained from a prompt or not. If the image has been upscaled, then we consider that prompt to be a good prompt. If it has not been upscaled, we are just not uh, like gonna keep the same prompt. We are gonna obviously optimize that prompt to have a better output. So that's how LSTM model comes into play, where we are basically using the LSTM model to identify if it has been upscaled or not. RNNs. RNN is the most like common type. Like every one of these models are actually RNNs, but this is like a basic one which we have used. So, and it's very common in NLP situations. It is also used for predicting whether this is like upscaled image or not. Finally, we look at GRU, which is also another format of RNN. This is specifically capable of maintaining relationships between sentences, and it can like show promise in generating coherent and relevant text depending on the model and dependency in a word of a sentence. We are also using it to predict the label for the upscaled images at the end of the day, but this is like one of the other models we have used for our purposes. Prediction. Now, the goal of our ML model is to predict whether a user given prompt would be upscaled or not, or as I mentioned before. Now, upscaling a prompt is a clear sign that the prompt is good, and if it's not upscaled, then we would need to optimize it for a likable outcome for the user. The accuracy of all three models, LSTM, RNN, and GRU, were all above zero point 0.7, which was a healthy sign that our predictions were coming out good. And we split the data into the ratio 2:8, as mentioned before. These accuracy values are definitely a good sign towards our desired outcome. Now, optimization. I initially planned and used a lot of optimization techniques with my code, but too much incoherent things were coming up and too much noise was popping up even after I tokenized and vectorized all my prompts into like smaller tokens, and even then it was not functioning at the best of things. So I decided to use an optimizer for the process. So the two ways that I found out how to like optimize prompts in a very easy and simplistic way, which would directly like increase the prompt, like the image's quality and the image's like more desired image, right? Would be either adding realistic detail in front of every single prompt. These two modifiers increase the likelihood of getting a better image by a long margin. And the last and more reliable method that I have used is actually asking ChatGPT to act as an optimizer and to optimize the user prompts which have been deemed non-scaled to get a better enhanced image for our users. These are some examples of optimized results I got from ChatGPT. As we can see that ChatGPT had actually come up with a whole paragraph of things to uh, actually describe that particular image, which might be a bit too much, but this definitely increases the complexity and the beauty of the image by a long margin. I have asked ChatGPT to narrow down uh, our optimized results into a single sentence, and some of them are as follows. So we used the prompt Ronin Warrior, whereas ChatGPT came up with a lone Ronin Warrior stands atop a wind-swept hill. It just creates a more better outcome, like a more desired outcome. Even this, the AI I used for this is like pretty great. And this is an example of how like a lightning dragon becomes like hype, and it becomes better when I use the words hyper realistic and detailed, as we can clearly see that the lightning dragon in the original prompt was pretty nice, but the one in the hyper realistic one and detailed one had a way more weight and definition to it, which the original one did not have. This is the final one, which I also use ChatGPT to demonstrate. Even though the mermaid image is nice, the one with the ChatGPT enhanced one is on another level. So the next steps I would discuss would be like the further improvement ideas. So most of the times users are not aware of what they exactly want. No one is actually aware of what they want until they are near what they want. Everybody has a general idea. So one of the thought processes I had would be to add more variations based on words which extremely modify images. This would help users uh, like like get better outcomes and stuff. It would like we could use specific styles which are like keyworded for our particular AI model, which would give users more idea, basically creating variations of that particular prompt to generate like more options for the users in a limited fashion so that the user can easily choose between them. In conclusion, our desired outcome for this project, as we have talked about, is to create better text prompts for our users. These text prompts themselves would like basically have like better images outputted from them when we put those text prompts into mid journey. These would I we are identifying who to scale, like I mentioned, through our ML models from the upscale level from our data. Yeah, we are aware of the potential ethical implications of AI generated art, and there were a lot of laws being put out here and there to control the like the art industry and the creative industry. Our research focuses on improving prompt optimization for AI art, and we do not claim ownership or authority of any generated art. We also ensure that generated art does not infringe on any existing copyright or intellectual property rights. We ensure that our data collection and analysis adhere to ethical standards by obtaining the necessary permissions. Additionally, I have removed sensitive and or personal identifiable information from our data set to protect the prompter's privacy. This was especially a case in for Discord messages, since every single username was and their email was popping up with the data set that I received. Thank you all for listening to my master's thesis presentation.